Forces Part 3. We know that previously we have studied about force, types of forces, and effects of forces. In video part 2, we studied about vectors and additions of vectors by head to tail rule and by parallelograms law of vectors addition. And then we did few questions from past papers as well. Today we are going to study about Newton's laws of motion and friction. So the topics for today is Newton's laws and friction. Now, balance forces in Newton's first law. We know that a body at rest will remain at rest if there is no force acting on it. Or we can say that a body remains at rest if the net force on it is zero. Suppose that here is a ring on which there are two forces acting. One is towards east, the other is west. Both the forces are 5 Newton each. So the forces are equal in magnitude and opposite in direction. So these forces cancel the effect of each other. The net force is zero and the acceleration is also zero. The body will remain at rest. It will not go anywhere. Now, if a body is falling from certain height, it is experiencing two forces. One is the weight of the body, which is always in the downward direction. And the other is the air resistance, which is also known as fluid friction, which is upward. Now, initially, the weight of the body is greater than the air resistance. Why? Because initially, the body is moving slow, so the air resistance will be less. As the body speeds up in the downwards journey, so there is air resistance increases. And finally, air resistance becomes equal to the weight of the body. And when both of them are equal, this body falls under the action of no net force. That is, the net or the resultant force on the object will be zero, acceleration will be zero, the body will be falling with constant maximum velocity, and that velocity is known as terminal velocity. So when the body falls with the terminal velocity, there are two forces acting on it, and both are balanced. So the resultant force is zero and the acceleration is zero on it. So from the above discussion, we can state Newton's first law. In the absence of an external net force, a body at rest will remain at rest and a body in motion will continue its motion in a straight line. That is, the resultant force is zero, the acceleration is zero. This is the mathematical form of Newton's first law. Inertia. Inertia is the property of a body due to which it resists any change in a state of rest or uniform motion. Newton's first law is also called law of inertia. There are different examples of inertia. For example, a coin placed on a cardboard is dropped in the glass when the cardboard is given a push with a finger. Similarly, a person standing in a moving bus falls forward when the bus slows down or is stopped because of inertia. Unbalanced forces and Newton's second law. When the resultant force acts on an object of constant mass, it is accelerated in the direction of the resultant force. That is, when force is applied on a body, it moves in the direction of net force. Or we can say that acceleration is produced in it in the direction of net force. Mathematically, Newton's second law is written as F is equal to ma, where m is mass, a is acceleration, and F is net or resultant force. We know that if we apply more force on a body, its acceleration will be more, and vice versa. That is, if we increase the force, acceleration increases. But if the mass is constant, and for constant force, if we increase mass, acceleration becomes smaller and smaller. So from this we see that acceleration is directly proportional to force and acceleration is inversely proportional to mass. Combining these two cases or these two equations, we can have F is equal to ma, which is Newton's Second, the mathematical form. If we put mass is equal to 1 kilogram in this equation and acceleration is 1 meter per second square, then we get F is equal to 1 kg meter per second square, and that is equal to 1 Newton. In system international, we call this part as 1 Newton. Or we say that the force applied on a body is said to be 1 Newton if this force is able to produce 1 meter per second square acceleration in a mass of 1 kilogram. Now, Newton's third law. Newton's third law states that for every action there is equal but opposite reaction, or action and reaction are equal but opposite in direction. For example, if a ball is thrown towards a wall, it hits the wall and bounces back. So the action force is the force of the ball when it is exerting on the wall, while as a reaction, the wall is exerting force on the ball. So you're going to mention forces in action and reaction, or forces which force is action and which force is reaction. So in this case, the action force is the force of the ball on the wall, while the reaction force is the force of the wall on the ball. Similarly, when the rocket flies up, when it moves up, so it is ejecting burning gases in the downward direction with a force. That force is known as action force. As a result, a jerk is received by the rocket and the rocket moves in the upward direction. So the action force is the force with which the burning gases are ejected in the downward direction, and the reaction force is the force with which the rocket moves up. Similarly, when we fire gun, the bullet moves in the forward direction and the gun recoils in the backward direction. So the force with which the bullet moves in the forward direction is the action force, and the force with which the gun recoils or moves in the backward direction is reaction force. There are so many examples of action and reaction forces. It should be remembered that action and reaction are pair of forces, but they never act on the same body. Friction. Contact force which opposes or tends to oppose the motion between surfaces in contact. Surfaces in contact are mostly irregular or uneven or rough, which is the cause of this opposing force to the motion of objects, and this force is known as friction. Suppose that these are two objects, object 1 and object 2, and you want to move object 1 on object 2. So we apply force on object 1. Suppose that the force applied is towards right. So there's another force which is acted towards left, and this force which is opposing our applied force in order to prevent the body from motion is friction force. Both the bodies are in contact with each other, and where they are contacting each other, there is a cause of friction because these surfaces are uneven or rough. Now, the larger the area in contact, the greater will be the force of friction. There are different types of frictions. Static friction. This type of friction is acting on bodies at rest. Why it is acting on bodies at rest? In order to prevent the bodies from motion. Kinetic friction acts on moving object in order to stop them. Limiting friction is the maximum value of static friction to prevent the body from motion. Sliding friction acts on objects which are slided. Rolling friction acts on rolling objects. So if we see in case of rolling, the surfaces in contact is less as compared to sliding. So that is why we convert sliding friction to rolling friction by using bearings and wheels. There are positive as well as negative effects of friction. So positive effects or advantages of friction. Walk without slipping is due to friction on the ground. If there is no friction on the ground, we will not be able to walk. Applying brakes to stop or slow down is due to friction. Climbing on mountain to have firm grip, chalk is used on hands in order to have friction. Skydiving and control of speed during it using air resistance, which is also due to air friction. Negative effects of frictions are that the efficiency of vehicles is reduced by 20% because of friction. The heat is produced and the energy is lost or wasted. Due to this thing, there is increased fuel consumption as well. So 20% of efficiency is reduced and more fuel is lost because of friction. Wear and tear also occurs in the parts of the machinery, and that is why we are going to spend money on machinery and we are going to replace the different parts periodically in order to have good functionality. It's for your information. The study of friction, wear, lubricants and design of bearings, the science of interacting surfaces in relative motion is called tribology. It is just a general knowledge point. Now the friction is having good effects as well as bad effects. That is, it has advantages as well as disadvantages. So we need to reduce friction because it has advantages. So these are the methods to reduce friction. As in case of rolling, the area in contact of the wheel with ground is less as compared to sliding, so we convert sliding friction to rolling friction. For this conversion we use wheels and bearings. Lubricants are also used on large scale domestically as well as industrially in order to reduce friction. Surfaces are polished in order to reduce friction. Creation of thin air cushion between two surfaces also reduces friction.